In this video, I am going to explain one of the question from the model paper, which is important. The question is from module 3, that is question A, in which we have to perform ID3 algorithm to solve this given training data set. First of all, calculate the number of S and number of no's from the job offer. This is our target attribute here, and this is our test instance in which we have 4 attributes, and this is our target attribute. Here calculate the number of S and number of no from the target attribute, that is job offer. Here we have 7 S and 3 no. Now the first step is to calculate the entropy for the target class, that is job offer. Here we have to calculate the entropy for this target attribute. We are calculating the entropy for this job offer in the first step, that is job offer. Here we know the formula to calculate the entropy information. Here we have 7,3. Here we have 7S and 3 no. So we have to calculate the entropy now. 7 by 10. 10 because we have total number of instances are 10. So we have to take the denominator as 10. The number of S divided by total number of instances, and log 2 divided by 7 by 10, plus again same here log 2 3 by 10. If you calculate this, you will get 0.88129. Now we got the total entropy of our target attribute, that is 0.88129. Now we have to perform the iteration. In the first iteration 1, that we are going to perform step 2. Here we have to calculate the entropy and gain for each attribute. Here we have to calculate the entropy for this attribute and this attribute, and for these four attributes we have to calculate the entropy, and we have to calculate the gain as well. First of all, I am going to calculate the entropy for this CGPA. Entropy for CGPA. As we have the target attribute as job offer, we have to take this, which consists of S and no, and the total, and here entropy. For CGPA we have 3 types of instances here. This one, and this one, and again this one. We have 3 types of instances we have. It is, so I'm going to take each instance. Here greater than equal to 9. Here we have first instance, the second instance, and the third instance. Now we have to check for this instance what are the number of S job offers we have. Here for this we have to look over here. For this instance S is 1. Here we have no, we can't take this. We have to count the number of S here. 1, 2, and 3. Yeah, we have 3 S, and here 1 no for this, and yes, here we have 1 no for this instance, and total if we add these two we will get 4. And entropy is nothing. We have to calculate the entropy for this. Now for this instance we have to see the number of S and no. Here we have 1, 2, 3, and 4. 4 S, and number of no we have 0 nodes. That means we have total as 4 and entropy is 0. If any one of these becomes 0, then the whole entropy will become as 0. Here for this instance now, we have 1 no, sorry, we have to see for S, right? First we don't have any S, so it will become 0, and we have 2 no. Here we have 2 and this is 0. Now we have to calculate entropy for this instance now. In the same manner, we have to calculate the entropy here. Entropy information, that is our target attribute in CGPA. Now we have to calculate the entropy for this instance. We know how. Here we have to take this as a total, and the total number of instances in this table we have, that is 10. Now we have to take here minus. Here in this we have taken minus out, but in this, while calculating this attributes, while calculating the entropy for each attribute, we have to take the minus inside like this. And for the S we have 3, and total number of instances for S is 4, and log 2 divided by same, and we have to take minus again. And for this, no, 1 divided by 4, log 2, and 1 divided by 4. Now for this we have to take plus. Again we have to take the 4 divided by 10, minus again, and for this 4 divided by this 4 again. Total number of, and log 2, 4 by 4, again minus, and this 0 divided by 4, log 2, and 0 divided by 4, plus again here we have to take this 4 by 10 again, and now we have 0 here. 0 by total is 2, log 2, again 0 by 2, minus, sorry, I have not taken here minus. Here we have to take minus, again minus, and it is no is 2 by 2, log 2 by 2. Now we have to calculate it. 4 by 10, if you calculate this, you will get 0.3. If you calculate this whole, you will get 0.81127. For these two, we will get as 0 plus 0. Now after solving it, we will get 0.3245. Now we got the entropy for this attribute, and now we have to calculate the gain for CGPA. Here we have to take total entropy for this attribute. We have calculated this as, this is our total entropy for all instances, minus attribute, individual attribute. Here we have 0.88127 minus 0.3245. We will get 0.5562. Similarly, we have to calculate entropy and gain for each attribute. Moving forward, we have to calculate entropy and gain for this attribute in a similar manner. Now entropy for this interactiveness. You can see here we have only two types of instances, that is S or no. Here S and no. See the number of S for S: 1, 2, 3, 4, 5. Here is 5. And for no, S should be no in a target attribute. S. Here we have 1 no. 1. Similarly for no we have 2. This will be, we have to calculate entropy for these two instances now, in the same manner as we have calculated for CGPA. Entropy information for interactiveness. Here for this now, S, this is 6 by 10 minus 5 by 6, log 2 5 by 6 minus 1 by 6, no, plus This is 4 by 10. Sorry, here should be 4. This 4 here. If we calculate this, for this you will get 0.30. Total it will be 0.7900. Now we have to calculate the gain for interactiveness. That is total entropy minus this value. Total entropy is this. We will get 0.09129. Now third attribute is practical knowledge. In this we have 3 types of instances: very good, good and average. For these 3 we have to form the table. Here we have to check the number of S for this very good instance. I have taken here very good instance. For this we have 1, 2 as S, 2S and 0 no. That means the entropy we will get as 0. Here we will get 4, 1 and 5. We have to calculate entropy for this and this also. Now using formula, practical knowledge. For this we will get 0, so I am not going to take this. Here we have 4 by, this one. Here it is 5 by 10 minus, I am not calculating for this, I am calculating for this instant. 4 by 5 log to 4 by 5 minus 1 by 5 log to 1 by 5 plus, and for this now 3 by 10 minus 1 by 3 log 2 minus 2 by 3 log 2. Here we will get 0.3609. If we calculate this, we will get this, plus for this we will get 0.2753. Total is 0.6363. Now we have to calculate gain. Gain for practical knowledge, we will get 0.8807 minus 0.6363. We have 0.2449. Now entropy for the last attribute, that is communication skill. In this we have 3 types of instances: good, moderate and poor. Now you have to check here. For good we have S. How many number of S we will get? 1, 2, 3, 4. We will get 4. And no is 1. That means total will get 5. Now we have to calculate entropy for this. Here we will get 3. We have 0, 3. That means we will get it as 0 to 0. If we have any of this as 0, we will get the entropy as 0. We have calculated the entropy for communication skill in a similar manner as we have done for other attributes. Here I have calculated the entropy and the gain. Now we have to take all the gains of all attributes in a single table. Here I have taken all the gain for all the attributes, that is CGPA, interactiveness, practical knowledge and communication skill. Now we have to perform the third step. In the third step we have to draw the decision tree for the iteration 1, which we have solved until now. Now from this table we have to choose the attribute which have the maximum gain. Here you can see that CGPA has a maximum gain, so we have to take this CGPA as a root node and we have to construct its subnodes. Here I am taking the CGPA as root node, CGPA, and what are its attributes? Its attributes are, here we have 3 attributes. We have to take these 3 attributes and we have to draw the subtree. Here I have taken the CGPA as a root node. As the CGPA has 3 attributes, I have taken these 3 attributes as a. In this table you can see that for this attribute and this attribute we have got 0 as an attribute. So this ends here only. We have to find the entropy of this again until we get a 0. For this attribute I have to take the table again from the question. Here we have to choose the same attribute for which we are going to find the entropy. Here I am taking this one, first one, not taking the CGPA as it is root node. I am directly taking the interactiveness and practical knowledge and communication skill and job offer. For this attribute we have interactive as S, practical knowledge very good, communication skill good, and this is S. We have to take only these attributes only, this attribute only. Again here we have this again, it is no, average, poor, no, average, poor, no. And next here we have this as S, good, moderate, and this is also S. Again the last one is here no, very good, and S. Now we have to find the entropy for each attribute again, and we have to find the gain as well. We have to perform the same procedure as we have done previously. Let's take it as iteration 2. The total entropy we have to calculate first. Entropy information. Here number of S is 1, 2, 3 and no is 1. Here to calculate this we will get 3, 1. Then we have total as 1, 2, 3, 4 instances. We have to take as minus 3 by 4 log 2 3 by 4 plus 1 by 4 log 2 1 by 4. If you calculate you will get 0.8108. Now entropy for interactiveness. Here we have S and no as a 2 attributes, right? For S we have 1S, for S we have 2S, and for no. First let's construct the table for this. Here for interactiveness, job offer equal to, in interactiveness we have only 2 types of attributes instances, S and no. For S we have 1S and 2S. Here it will come 2, but we have no's for this S attribute. It will come 0. That means the total is 2, entropy is 0. Again for no the number of S is 1 and number of no is 1 and 1. Total is 2. We have to calculate the entropy for this. Entropy information for interactiveness. Here we have total as 2 by 4. minus, here for S we have 2 by total is 2 log 2 2 by 2 minus, this is for no 0 by 2 log 2 0 by 2, this is whole is equals to 0 only, plus 2 by 4 minus 1 by 2 log 2 1 by 2 minus 1 by 2 log 2 1 by 2, which will be equals to 0.4997, and we have to calculate the gain for it now. Gain of interactiveness. The total entropy is 0.8108 minus entropy of this 0.4, which will be equals to 0.3111. Similarly, we have to calculate for this practical knowledge and communication skill. Here I have calculated the entropy for practical knowledge and communication skill and gain also. And now we have to take these gains in a single table. Here I have constructed a table for each attribute with a gain. Again, we have to construct the decision tree for this table. Now consider the maximum gain, as this and this have the same values. We can take this. We have to continue the previous decision tree, and we have to construct the new decision tree. We have to take this tree as well, and we have to construct the new decision tree. Here I am taking this practical knowledge as the root tree. First take this CGPA. As I am taking the practical knowledge as a root node again, for this instant I am taking this here. For practical knowledge, we have three types of three instances here. That is here, good, very good, good, and average. We have to take these three instances. Let's take this in a diamond. Here we have good, average, and very good. Now for average, we got job offer as a no, and this as S, and again this as S. Let me tell you how I constructed this tree over here. While calculating the entropy for practical knowledge, here we have to take this table, right? In this table you can see that the entropy of each instance we got as 0. That means this decision tree will end here, because we have got the entropy value as 0. When we get the values as 0, we have to stop the construction of decision tree. Here how I take this job offer as S no. Here we can see that here we have for very good, we have job offers are 2. That's why the job offer we have taken is here as S. And again for average, we have taken the job offer as no, because here job offer value has 1. So we have taken the job offer as no. Again here we have good has the 1 value in a S. That means job offer we have got as S. Here that's what I have taken. This is how we have to construct the decision tree. This is our final decision tree. If we haven't got the entropy value of these as a 0, then we have to again we have to take the iterations, and we have to calculate the entropy and gain, and again we have to perform the same steps again and again until we get the entropy of all instances as a 0. This is how we have to calculate the ID3 problems.